In this video, we're going to be making this molecule, and this is about reactions of aldehydes and ketones, but we're going to find several strategies. So what we're going to be doing here is use what we call a disconnection approach. So I'm going to disconnect these two and figure out the fragments that we can use to make this. So one possible way is starting from there's aldehydes, so it will be 3 carbons, so it's propanol. And I could use this fragment to make a Grignard reagent. So if I make the 2-bromopropane, I make that react with magnesium. I'm going to make this magnesium bromine. And that is one approach that I can do. So if I put a minus, a plus, I can do the nucleophilic attack over to the carbonyls. I'm going to do this. Remember that here we have an H. And at that point, we will get an alkoxide. And of course, we, here you have, I'm not drawing the H anymore, but instead I'm going to be drawing this. Remember that the H here, I don't have to draw it. When we do line structure, we can omit that. So that is the alkoxide. And then we use, of course, proton transfer. So we need a source of protons to get the alcohol. So that's one possible disconnection that we can do here. Let's try another. So I can think of now this disconnection. So I'm going to do another Grignard in this case. Now what I'm doing is I'm going to be starting with this alkyl halide. And now I'm going to be using this compound. This is, again, another aldehyde. And I'm going to be using ethyl bromide to do ethyl magnesium bromide. And then these, I'm going to make it react. See, here, notice this is 1, 2, 3 carbons. So it's propanol, but it's 2-methyl propanol. 2-methyl propanol. And this is ethyl magnesium bromide. Well, we know that we prepare that from the halide with dry ether and magnesium turnings. So this is going to be now my nucleophile attacking over here. So to get the product that I want, of course, I'm going to get an alkoxide initially. So similar to that, let's throw it. So the product will have O negative, the alkoxide. So here I'm going to have this and the ethyl. Again, I didn't do the H, same that I did here. And I need a proton transfer step, so I need a source of protons. Again, I need to add acid. So these two strategies involve a Grignard. Since I'm having a secondary alcohol, there's 2 ways to disconnect that to make a Grignard. There's still another way in which we can do this. So now I'm going to imagine this alcohol coming from an alkene in that I do hydration. So if I do that, we'll put, for example, this alkene. So I'm starting, say, here. That's my target. And this time, what I'm thinking is that I start with that alkene. To go from this to my target, well, I will need to do hydration reaction. And in what way? Well, I need to figure out, I need to put the H here and that hydration and the OH here. That is an anti-Markovnik of hydration. And so what reagent do I need to use? So to go from here to here, I need to use borane in THF to do my anti-Markovnik. So hydroboration oxidation is a condition that is going to get me from the alkene to the target, to the alcohol. But how do I synthesize this? And again, I'm going to disconnect here. That can come from this reaction, making an alkene. You can do a Wittig. For example, you can have two fragments such as acetone. And I'm going to have a fragment with 1, 2, 3 carbons. So 1, 2, and 3. And this I'm going to make it react with triphenylphosphine. Remember, we need to make the elide. So that one fragment, this part, this here, is the acetone part. And I need to make that elide that I'm going to be to insert there. So I use triphenylphosphine. The first step involves an SN2 reaction. And so I'm going to write it on the side. After that SN2 reaction, I'm going to make this. And now I have pH3 and I have a formal positive. Remember that when we do Wittig, we need now to use a strong base such as N-butyl lithium. And that is to remove one H here. So now I'm going to have a pair of electrons and a negative charge. This is my elide, and that's positive formal. I can do a double bond. The resonance structure here will have a double bond and no longer have a formal charge, right? This is what you are inserting here. So I'm going to insert this over here in place of the oxygen, and taking these two fragments together, I'm going to get the alkene. Again, this two, let's name it with letters, say A plus B. I'm going to get the alkene C. And to get to the target, which is my alcohol, and I'm going to call it just D, I need to use this. So summarizing, I have 3 strategies, 2 involving Grignard reactions over aldehydes, and to get a secondary alcohol here. And the other strategy involves anti-Markovnikov hydration and a Wittig reaction. That is a Wittig. So if you're being asked to, say, summarize, to give the list of reagents, so let's do that. In this case, well, I kind of don't have a room, but I'm going to remove things here. So to do, for example, the first strategy will involve using acetone. This is strategy, the last one, I'm sorry. So you use acetone, and you put that with your elide, and you know how do you need to make it. Your elide is this reaction that we did, that's your Wittig. You get the alkane. The second reaction was this hydration, so hydroboration, and then you do oxidation. That is your anti-Markovnikov hydration, and we get the alcohol that we wanted. The other strategies are then, again, Grignard. You can do, when you have a secondary alcohol just like that, we can do 2 possible disconnection. The thing is now, decide what strategy is best. In terms of yield, when you're doing the Wittig, this strategy is good because we have a primary alkyl halide, and the first reaction here is an SN2. So that's going to work, and acetone is easy to find, so that the strategy works perfectly. Here, when the step right here is, that's a secondary alkyl halide, so not as good as having a primary alkyl halide for that strategy. But see, here you have options, and now it comes down to what is the best yield and the reagents that you have at hand to choose the best synthesis strategy.